Hello, friends. I hope you all are fine. So, let's start the topic. So, our topic is matrices, and in that, also, we are going to cover the basics of matrix. Yeah, so let's start. As I have shown over here, A is a matrix, and Aij is the element in ith row and jth column, and M cross n, like I have written cross over there in the middle. So M cross n is known as the order and size of the matrix. You can see over here I have written. And here the M shows the number of rows and n shows the number of columns. For example, we have a matrix like this. I can write number 1, 2, 3, 4, 5, 6, 7, 8, 9. So here, this is considered as a row and this is considered as a column. So this is the first element, which is known as A11. This is the second element of the first row, which is known as A12, and here it is A13, like this. If I talk about these elements like 1, 5 and 9, they are the principal diagonal elements. And if I consider this 2, 3 and 6, this is known as upper triangular, this is upper triangular, and this 4, 8, 4, 8 and 7, these are known as lower triangular elements. Okay, so this is the general basic idea, and this is the 3 cross 3 matrix. You can say there are 3 rows and 3 columns of this matrix. Okay, yeah. So the second point says if m equals to n, then it is a square matrix, and if m not equals to n, then it is known as a rectangular matrix. In general, we prefer to use square matrices because when we find inverse, when we multiply the matrix, it is easy for us to get more precise results in the square matrix. But yeah, matrix is just the data. It is not mandatory that it is always a square matrix, but yeah, we have two type of matrices. One is square matrix and another one is rectangular matrix. Okay, so next point is operation on the matrix, and as you all know, we have addition, subtraction, like a plus b, a minus b, and yeah, for the addition and subtraction we must have the order of a is equals to the order of b. This is the mandatory condition, or you can say necessary condition to make an addition possible of the two matrices. The next is the multiplication. So in multiplication, for example, if you want to multiply this a matrix with the b matrix, the possible condition is like this: n and p should be equal. I have written over here n and p must be equal. Here is very important formula, like in GATE, ESE and any competitive exam, they may ask you these kind of questions. Yeah, so the first I have an assumption like A is m cross n matrix and B is p cross q matrix, and we have n equals to p, which is the condition for the A and B multiplication. Okay, so the first point says the number of scalar multiplication required to find AB, which is of the dimension m cross q, is equals to m into p into q. This formula mpq you must remember. Okay, and the number of additions required for the multiplication of a and b is m into p minus 1 into q. This is also you have to remember. Okay, you will get to know these formulas when you try one question. At the end of this slide I have provided one question, uh, and even the solution I'll provide in the comment section, so you can try it your own that question first, and you can post your answer and you can verify your answer with the link which I'll provide in the comment section. Okay, the problems given on these two uh, points, they are very easy, so you can easily score marks in this uh, topic. Okay, the next one is type of matrices. So the first matrix is symmetric matrix. Um, uh, Actually I have followed one pattern. uh, when you consider all the types of matrices, I have given some information in the box, so whatever I have given in the box, that information you must remember. Okay, yeah. So the symmetric matrix is a matrix in which A equals to A transpose. When you okay, let me tell you what is a transpose. So yeah, transpose is like when you convert a row into column, like row is converted into column. Okay, this is the general meaning of the transpose. Like over here I have written transpose of a matrix is just like converting the row into the column. I hope you all know that. That's very basic thing how we calculate the transpose of a matrix. Okay, so here are the 2 points where generally we have a question in exam, and the first point is if A is a symmetric matrix, then A raised to the power n is symmetric matrix. If so, here I have written this statement is true. Yeah, this is true, and I have given the pattern also, like how it is true. For example, A is a symmetric matrix given to us, so A transpose is equals to A. When you raise the transpose to the power n, like in this equation, when you raise both sides with n, the equality holds good. So in that case, A transpose raised to the power n is equals to A raised to the power n, and with the power rule of the matrix, you can interchange the power. So A raised to the power n transpose is equals to A raised to the power n. So we can say this matrix transpose is equals to this matrix, means this is symmetric matrix. Okay, so this is the proof. The next is the product of two symmetric matrices is symmetric matrix. This claim is false. As you can see, A transpose equals to A and B transpose equals to B, as A and B are symmetric matrices. Now when you multiply them and you raise it with the transpose, so that will be equals to B transpose dot A transpose. As we know matrix multiplication, how we open up the matrix, here A into B transpose equals to BA. As you know, these A and B are symmetric matrices. From this equation you can directly write B into A. Since when you open up this AB transpose, this is B transpose into A transpose. As we know, the matrix follows backward multiplication. Okay, so B transpose dot A transpose equals to BA, and that's not equals to AB. When it is equals to AB, then only we can say it is a symmetric matrix, but BA we have got, so this is not following. Okay, you try this at your own and you will get more clarity. Okay, so the next matrix is skew symmetric matrix, and yeah, when A is equals to A trans minus of A transpose, in that case you can say it is a skew symmetric matrix. And here I have written uh, AI equals to 0 and AI j equals to minus AJI. Like over here, the principal diagonal elements are 0, and if I consider 3 and minus 1 over here, here it will be minus 3, here it will be 1. When I consider 2 over here, it will be minus 2 over here, like this. When you follow these two conditions, you will get a matrix like this. Like whatever the quantity over here, it should be negative present over here. If it is negative over here, it should be of opposite sign. Over here minus 2, here it is 2, and the leading triagonal elements all are 0. Okay, this is the skew symmetric matrix. Yeah, one more statement I have given over here. If A is a skew symmetric matrix, then A raised to power n is over here. Like in this case, when we solve it, like A transpose equals to minus A, this is the condition of the skew symmetric matrix. Skew symmetric matrix, and A raised to the power n transpose, like when you raise both the side with the power of n, you will get this particular step. And yeah, when you open up this A raised to power minus A raised to power n, you will get minus 1 to the power n into A raised to the power n. So when you raise it with the even power, you will get 1, and when you raise it with the odd power, you will get minus 1. So this minus makes difference, and when n is even, you will get A raised to the power n as a symmetric matrix, and when n is odd, you will get A raised to the power n as a skew symmetric matrix. Okay, so the next is Hermitian matrix. Before Hermitian matrix, I want to tell you one thing, like how to find the conjugate. In case of complex numbers, we can find the conjugate by just replacing I with minus I. For example, x equals to A plus iota b, then x conjugate, this is the symbol of conjugate, so x conjugate equals to A minus iota b. This iota is the complex. Okay, as you all know, these are very basics. Okay, so next point is like Hermitian matrix. Hermitian matrix, you can say the conjugate of A equals to A transpose. So here the conjugate of A is equals to A transpose, or you can say AI equals to real and Aij equals to conjugate of AJI. In that case, the given matrix is the Hermitian matrix. Okay, when you fulfill these two conditions, you will get the Hermitian matrix. As in this example, it will be more clear once you see this example. Okay, in case of Hermitian matrix, as we all know, AJI equals to A Aij equals to conjugate of AJI. So, and the leading diagonal elements will be real. So without changing it, you just write 2 3, and for this matrix to be Hermitian, you have 1 plus I over here. So basically this x will be 1 minus I. Here is the conjugation, like this. So the value of x will be 1 minus I. Okay, in case of skew Hermitian matrix, here the conjugate of A equals to A transpose with the negative sign. So AI equals to 0 and Aij equals to minus conjugate of AJI. Here I want to tell you one more point in skew Hermitian matrix. Here you can say either it is 0 or you can say purely imaginary. Okay, like even if it is purely imaginary, it will be fine. Like over here you can see this is purely imaginary, this is also purely imaginary. Okay, when this is skew Hermitian matrix, so x will be minus of the conjugate of 1 minus I, like this. So it will be minus 1 plus I. Okay, I hope you understand this. The next point is orthogonal matrix. A matrix is said to be orthogonal when A into A transpose equals to A transpose into A equals to I. You can say like this, or A inverse equals to the transpose of the given matrix. In that case, it is orthogonal matrix. As we all know, A into A inverse equals to I. When you compare this identity with this, you'll get A transpose as equals to A inverse. Okay, the next matrix is idempotent matrix, and yeah, there are few questions asked in previous year gate from the idempotent matrix itself. So here is like A square equals to A. When you square the matrix, when you multiply A matrix with itself, which is you get A square, which is equals to A. In that case, you can say it is an idempotent matrix. Here one statement you have to remember, this is very important statement. Let A and B of same size, AB equals to A and BA equals to B. These two are conditions. When they are fulfilled, you can write it like this. A plus B whole raised to power n equals to 2 raised to the power n minus 1, A plus B. For example, if somebody is asking you A plus B whole to the power 5, in that case you can write it as 2 raised to the power 4 into A plus B, like this. Okay, such questions also observed in previous engineering exams, competitive exams. Okay, the next matrix is involuntary matrix. Here the condition for the involuntary matrix is A square equals to I, or you can say A into A equals to I, and you can say A inverse equals to A. Like when an inverse of a matrix is equals to the matrix itself, in that case you can say it is an involuntary matrix. And the last matrix is nilpotent matrix. You can say nilpotent matrix of a degree or index k if you raise that matrix with that power, and you get the null matrix. Like all the element of matrix are 0 0. In that case you can say it is a nilpotent of degree or index k. Here k is the factor which is showing like of which degree the matrix is a nilpotent matrix. Here I have given you two questions. Both are very easy questions, and you just try and find in the comment section. I am providing the solutions as well. Okay. Okay, there is a quick revision. You can see over here for the symmetric matrix, um, you have A transpose equals to A. For the skew symmetric matrix, you have A transpose equals to minus A. For the Hermitian matrix, you have A transpose equals to conjugate of A. And for skew Hermitian matrix, you have A transpose is negative of the conjugate of the A. The next is orthogonal matrix where A transpose is equals to A inverse. Like till here you can say it is of transpose. And here you can say it is related to the square property. Okay, so idempotent matrix is A square equals to A, and for the involuntary matrix you can say it is A square equals to I. So this particular matrix, you just remember this table. It will be very easy for you to answer the questions related to the types of matrices. Okay, yeah. So try these questions and let me know answers in the comment section. Okay friends, thank you.